With joint variation, what we see is that we have two variables that vary with, there we go, two variables that vary to give our third variable, which is our output. For example, we have v equals pi r squared h, which is in fact the equation for the volume of a cylinder, where we have h and r, and v equals pi r squared h. This tells us that volume varies jointly as h in the second power of r, or r squared. So we know that as r squared h gets bigger, v gets bigger. And that in fact, as h gets bigger, if we were to just increase h, then v would get bigger. Or if we were to just increase r squared, then v would get bigger. Let's look at part B. We have y equals 1/4 ab. In this one, y varies jointly as a and b. So as a gets bigger, y gets bigger. As b gets bigger, y gets bigger. Or as ab gets bigger, then y gets bigger. If we were to generalize this, we find that y equals k times xy, or y equals k times x to the n, y to the mth, where n and m are both natural numbers. And this is for joint variation. Let's look at example 4. I want you to write the equations for the following statements. Again, try this on your own first, and then resume the videos when you're ready to see my solutions. Alright, let's give us a little bit more space. For the first one, so for part A, we know that A varies jointly as B and C. Again, we're going to use the constant of proportionality K. And this means that A will equal B times C times some value K. So A equals K BC. Okay, in part B, we have A, capital A, varies jointly as the product of 2.5 and the cube of y and the square of z. Here we have A, which varies with 2.5 times the cube of y and the square of z, and all of that times some constant of proportionality k. Lastly, y varies jointly as A and inversely to c. This means y will equal A, the inverse of c, all times some constant of proportionality k. So y equals Ka all over c. And those are all examples of varying jointly. The most important thing to remember for any of these is that once you set up the equation, you have to remember to put in your constant of proportionality k. We see that with the direct variation, the inverse variation, and the joint variation. And this value k can be any real number. It just has to be a fixed number. And that's it for variation.